Now we're going to talk about division. When I talk about division, here notice I'm dividing by a monomial, because I can rewrite this as minus 2q to the 6th minus 8q to the 10th. Fractions are really the same as division. So it looks like some polynomial divided by a monomial, one term. Now remember how fractions work. If I have a over b plus c over b, since they have a common denominator, I can add them together, right?
Yes.
I'm kind of going to go this way. I have two terms over some number. I'm going to actually split them up. And I'm going to say this is minus 2q to the 6th over minus 2q squared plus minus 8q to the 10th divided by minus 2q squared. So I went from having them both on the same fraction with a common denominator to splitting them into two separate pieces where they have a common denominator. Why do I do that? Well, it's because it makes things easier. Because the minus 2's cancel. And what do I end up with? I end up with q to the 6th over q squared plus, and I have minus 8 over minus 2 is 4. Q over q squared. And then do you remember how to simplify division with exponents? You could simplify each one separately. So q to the 6 over q squared is what? We have our division rules, remember from last time. This is q to the 4th. So then I have plus 4, and I have q to the 10th over q squared, which gives me what? 4q to the 8th. B to the m divided by b to the n is equal b to the m minus n. If you don't remember these, review them. They will not go away. I have a binomial divided by a monomial. So I can just say 2a to the 10th, b to the 10th, minus 4a to the 6th, b to the 6th, divided by 2a cubed, b cubed, which equals, I can separate this into two separate fractions. And now I simplify. I can cancel 2 with 2, and I have a to the 10th over a to the 3rd gives me what?
A to the 7.
Perfect. And then I have b to the
7.
perfect. I subtract. I have 4 over 2 is
2.
2. A to the
3rd.
b to the,
B to the 3rd.
that's it. I'm done. That's division with a monomial in the denominator. Anytime you see division with a monomial in the denominator, you can just separate them out and simplify each one separately. But now look what we have. We no longer have a monomial in the denominator, do we? This one is not a monomial anymore. This is a polynomial divided by a binomial. Anything that's more than a monomial, we're going to have to use long division. 327 divided by 6. We're going to do polynomial long division. I'm going to show you how they're similar and how they're a little different. I look at 6 go into 3, no. 6 goes into 32, yes. 5 times. 5 times 6 is 30. I subtract. I get 2. I bring down the 7. I get 27. 6 goes into 27 4 times. 4 times 6, 24. I subtract and I get 3. This is my remainder. I can write this as 54, remainder 3. But there's also another way. I can write this as 54 and 3 over, that's my remainder, over the divisor, which is equal to 54.5. We can see now we no longer have a monomial in the denominator. We have to do long division. What that means is I'm going to rewrite it as 14x squared minus 43x minus 22 divided by 7x plus 3. It's going to be similar but a little different because I'm going to say the leading term divided by the leading term, which would be this, because we can't divide 6 into 3, so we take the next two numbers and divide it by this. We have 14x squared divided by 7x equals 2x, right? I put my 2x here. I multiply 5 times 6. I multiply 2x by 7x plus 3. And I end up with 14x squared plus 6x. I'm subtracting all of this. Now, the best thing to do, since I'm subtracting, let's get rid of the parentheses, and I'm just going to change all my signs, because that's really what happens when you subtract anyway. This goes away. 14x squared minus 14x squared. That's my goal. My goal is always to get rid of the leading term. And I did. And then I have minus 43x minus 6x, which gives me minus 49x. And then I bring down the minus 22. That's the first step. Now I'm going to just continue to do the same thing as many times as I need to. I'm here, and I say leading term over leading term. Leading term is minus 49x divided by 7x. Negative 7 is the answer. I put minus 7 here. And then I multiply minus 7 times 7x plus 3. I get minus 7 times 7x is minus 49x. And minus 7 times positive 3 is minus 21. Since I'm going to subtract, I'm going to change all the signs. This becomes plus, and this becomes plus, and then I add. This cancels. Perfect. It's exactly what I wanted to happen. Minus 22 plus 21 is minus 1. I could say that 14x squared minus 43x minus 22 divided by 7x plus 3 is equal to 2x minus 7, remainder minus 1. Or 2x minus 7 minus 1 over 7x plus 3. They're exactly equal, just two different ways to write it. The way this is asking, quotient is this, 2x minus 7, remainder is minus 1. Here's the quotient, and here is the remainder. Let's do another one. we have 12x cubed minus 10x squared minus 18x plus 1. I'm dividing it by 6x plus 4. Again, I just look at the leading term over the leading term, which is 12x cubed divided by 6x. What does that give me? 2x squared. I put 2x squared here, and now I multiply x squared by this whole thing. I get 12x to the third, and then 4 times 2x squared is plus 8x squared. Then I take my 2x squared and I multiply it by 6x plus 4.
Mhm.
And that gives me this. I subtract, which is the same thing as changing all my signs. If you don't do it like this, it's okay, but you better be very careful. The changing the signs thing is really helpful. You're going to make mistakes if you don't do exactly what I'm telling you. Most people will make mistakes. This cancels, which makes me happy. That's my goal, always to cancel the leading term. And then I just add. So I have minus 18x squared minus 18x plus 1. I do exactly the same thing again. Leading term over leading term, which means minus 18x squared divided by 6x. That's my leading term divided by my leading term, which gives me minus 3x. And then I multiply minus 3x times both terms. Minus 3x times 6x is minus 18x squared. And then minus 3x times 4 is minus 12x. I change my signs and I add. I get minus 6x plus 1. Continue until the degree of the new dividend is smaller than the degree of the divisor. So what does that mean? It means when the degree of this is smaller than the degree of this, I'm done. But they're still equal, aren't they?
Yes.
So I have to keep going. I'll do another one. Minus 6x divided by 6x minus 1. Then I multiply minus 1 times 6x plus 4. And I get minus 6x minus 4. I change my signs. And I add. This cancels. And I get 5. The answer to this is 2x squared minus 3x minus 1. This is the quotient. 5 is the remainder. I know this looks even worse, but it's all the same. And you always want to get rid of the leading term. That's always our goal. Let's do this one too. We have 42x to the third minus 45x squared. Now, a lot of people like to leave a 0x here because there's some place to put it under if there's an x. And then we have 6x squared minus 3x minus 2. Again, leading term over leading term. 42 divided by 6 is 7, and x cubed divided by x squared is x. So then I multiply and I get 42, x to the third. That's my leading term times the quotient. But then I multiply that 7x times all the terms. So I get minus 21x squared. And then I get minus 14x. Well, now you can see why it's helpful to put that 0x in there. It gives you the place to put the x. Now I'm going to subtract. When I subtract, all I need to do is change all my signs. And then I add. Cancel. Minus 24x squared plus 14x plus 5. Guess what we do next? Is the degree of this smaller than the degree of this?
No.
They're equal. So we have to do it again. We do it until it's smaller. Now I have minus 24x squared divided by 6x squared. That gives me minus 4. And then I multiply minus 4 times 6x squared minus 3x minus 2. And I get minus 4 times 6 is minus 24 x squared. Minus 4 times minus 3 is plus 12, and then times x. Minus 4 times minus 2 is plus 8. Then I change my signs. This becomes positive, this becomes negative, and this becomes negative. If you want, you can erase what's underneath. Now, I add. This cancels. Remember, the goal is always to cancel the leading term, and we keep doing it. So we get 2x minus 3. Is the degree of this smaller than the degree of this?
Yes.
Then I'm done. My answer is 7x minus 4. That's my quotient.
And the remainder is 2x minus 3.
My remainder is 2x minus 3. Now notice they want us to put it in different.
Right.
What goes in here? Remember, I was trying to show you this before. In this box, 7x minus 4. That's my quotient. The remainder goes here, 2x minus 3. And that's really it. It's really one technique over and over and over until you get to the end. And how do you know when you get to the end? The degree of this is smaller than the degree of this. That's when you know you're done. This is the remainder. This is the quotient. This is the dividend.